Okay, welcome. You're back for lesson 8.2, and we're talking more about sampling distributions and the central limit theorem, but this time is for proportions data or qualitative data. So let's just remind ourselves that a population portion is the proportion of a population who have a certain characteristic. A sample proportion is the proportion of a sample who have a certain characteristic, which means this is called p hat. It's x divided by n, where x is the number of successes and n is the number of trials or sample size. Okay, so it says, what is the sampling distribution of sample proportions and how does it work and what does it imply? So it says, we are interested in studying iPhone usage among US college students. A 2016 large study found that 69% of all US college students have an iPhone. So we will assume that the population proportion is 0.69. How many students are there in class today? So there are 45 of you. How many students in our class have an iPhone? We're going to say 24. So what is p hat for our class? So that would be 24 divided by 45. And that comes out to be 53.3%. 0.533. Now, suppose we go from class to class, polling students and finding each classroom's percentage of iPhones ownership. Describe the distribution of the proportion of iPhones from each classroom. This is called a sampling distribution of sampling proportions. Just like we did with the example in class with the exam scores of the different sizes of samples from that exam score from my other class. So we said the shape should be approximately normal. And the average of the sample proportions should be about the proportion from the population, which should be about 0.69. And the spread of the proportions is going to be the standard error, right? We called this standard error. Let's remind ourselves back from 8.1 is equal to this new formula. This all has to be under the radical here. P hat times 1 minus p hat, all divided by n. Or you can also do the square root of p hat times q hat. Remember, q hat is the same as the complement of p hat, all divided by n. So for us, this would be the p hat is 0.69 times 1 minus 0.69 all over n, and we said in our sample there were 45. Okay, these formulas are on the next page in our course pack in 2 pages, so don't worry, we're going to reintroduce it again. I'm just kind of introducing it a little bit early so that you can catch on. So I'm just going to show you here. So this square root of, the square root of, and then I'm going to do alpha y equals for a fraction. I'm really going to zoom in so you can see this here. And this is going to be 0.69 parentheses 1 minus 0.69 parentheses divided by the 45 in our class. And oops, what did I type? Incorrect. I put an I. I don't know what that was. That is supposed to be a decimal. There we go. 0.0689. So our standard error would be 0.0689. So just like we said in the last lesson for 8.2, that the bigger the sample size, the smaller the standard deviation. It says 83% of all U.S. college students have iPhones. 4 different research teams surveyed 50 groups of college students with different group sizes. Size 10, size 20, size 30, and size 40. Match the survey team group to their group size to their corresponding sampling distribution graph. Note they are all drawn with the same x-axis scale. Explain how you can tell. So go ahead and check it out. So which team do you think they are? So the one that is maybe all over the place is going to be probably this one. Sample size 10. Down here. It's kind of all spread out. Okay. And then the next one that's spread out is going to be this one up here, B, samples of size 20. And then this one is becoming more normal, a little bit closer together. Sampling of size 30. And then the last one is going to be D, where we have the samples of size 40, where it's very normal and small standard deviation. So it says, what do you notice about the center and spreads of the standard deviations? The centers are all the same, approximately the same, right? And the second note is that the standard deviation, the deviation is getting smaller, the spread. Okay, so we're going to put this all together on the next page. So just like we did in 8.1, we talked about we have to have conditions that we can meet for our central limit theorem for proportions. The first one is that we have to have a random sample, which is the same as 8.1. Our samples have to be independent of the population, just like we said before, either showing that our sample size is less than 5% of the population, or we can say 20 times our sample size has to be less than the population size. But this is the condition that's different. When we're talking about proportions, to check for normality, we have to show this. We have to prove that n times p times q is greater than 10. You have to show me that this is an actual calculation. Calculate. Okay. Once these have been met, we can then say our shape is approximately normal. Our center is going to be the mean of the p hats, which should be about the same as our population proportion. And our spread is our standard deviation of the sampling distribution, and that should be approximately equal to the square root of p times q divided by n. Okay, remember that p, if we only have a sample information, then we're going to use p hat and q hat. Okay. Also, remember that samples are always independent if we are sampling with replacement. We're talking about our condition 3 again. This is different than 8.1. The large enough is not set in stone. It changes depending on the value of the population proportion. So that's why we have to show this calculation. N times P times Q has to be greater than or equal to 10. Okay. So let's look at example 2 here. It says, a researcher studying public opinion of proposed Social Security changes obtains a simple random sample of 45 adult Americans and asks them whether or not they support the proposed changes. If 15% of all adult Americans support the changes, how many more adult Americans does the researcher need to sample in order to ensure the sampling distribution is normal? So we need this to be met, okay? So our sample is 45, but we can just show that with 45, we have 45 times 0.15 times 1 minus 0.15. Okay, so that, let's just prove that this doesn't work. So that calculation comes out to be 5.7374. Okay, so it's less than 10. So this won't work. So we need to figure out what does n have to be to make this work. Okay, so let's go ahead and find that 0.15 times 0.85. So n times 0.1275 has to be bigger than or equal to 10. So we need to divide both sides by 0.1275. So n has to be greater than or equal to 10 divided by 0.1275, which comes out to be about 79. So it says how many more adults. So that means we have to say 79 minus 45. So 34 more adults to sample. Okay. So at the bottom of page 199, you can see that we have that decision matrix similar to what we had in 8.1, but we're going to use StatCrunch. So if you want to use your graphing calculator, you may do so using inverse norm and normal CDF, but we're going to use StatCrunch for my examples today. So it says a simple random sample of size n equals 876 is taken from a population where p is 0.12. Find the following. So we're going to describe the sampling distribution of p hat. So that's going to be our shape, center, and spread. Our shape is going to be approximately normal because we're going to assume that we met our CLT. So if we don't ask you to prove it, you can assume that you met the CLT. Our center, so the mean of the p hats is going to be equal to p, which we said was 0.12. And our spread, the sigma of the p hats, is going to be equal to square root of p times q divided by n, which in this case is 0.112 or 0.12 times 1 minus 0.12 divided by 876. Okay, so let's just check it out. So 876 is our sample size. And we get 0.10999. So 0.01099. So we could 0.01099. We can round this to 0.0110 because we're going to need that for StatCrunch. So let's look at what we're trying to find here with our graphs. It says find the probability that the p hat is greater than or equal to 0.135. So our p hat center is at 0.112. So 0.135 would be over here, and we want to find this. And then C's picture says only 10% of samples such as these have proportions smaller than p hat equal to what? Okay, So that is going to be the probability that p hat. Remember, in StatCrunch, it's going to say x, right? We have to remember that StatCrunch always uses the symbol of x, but ours, we're just, for what we're doing here is really the p hat, and it says smaller, so it's going to be a less than, and we're trying to find this, and we know it's 10% of the samples, so 0.10. So 10% of the samples are smaller, so we're looking for something over here, and we're trying to find that p hat where we know the center is at 0.12. So let's go complete these in StatCrunch here. So StatCrunch, our setup here is 0.12, and our standard deviation, which is our standard error, is 0.011. And we're talking about a less, this was a greater than, the first one was a greater than, and we said it's likely, what is it likely to be greater than? 13.5%, 0.135. And it says there's, the likelihood is 0.086, which is 8.6% of the population. The second one was, we know that 10% of the population is less than this sampling p hat. Oh, I did a greater than still, it's a less than. So we need to correct that, 0.10 is less than. And that was a p hat of 0.1059. So I'm going to show you, so we can all have the same thing on our paper here. And this is what we had for each of those. So what's hard about this lesson is that we're talking about proportions and proportions. So our center is at a proportion, which seems kind of odd to talk about. And then we're calculating probabilities or proportions. So that, it feels kind of odd in that respect. So let's move on to page 200. So page 200 says, in 2018, a Gallup poll asked 1,009 random adult Americans whether public speaking should be banned in the US, and 58% replied yes. What type of observational study is this? So we got a quick snapshot. This would be a cross-sectional quick snapshot, right? Verify the conditions for the central limit theorem are met. And there are 3 of those. So did they say we got a random sample? Yep, right here. So check. And once we've asked somebody, we can't ask them the question again. So it's without replacement. And so that means I have to do 20 times my sample size, which was 1,009. And this one could kind of go either way, because if I do 20 times 1,009, it would be 20,180. And I'm saying, yes, there's at least that many adult Americans in the US. And then the third one is NPQ has to be greater than or equal to 10. You need to show me this calculation. So this is 1,009 times P, which we said was 0.58 times 1 minus 0.58. And that comes out to be 245.79. And yes, that's bigger than 10, check. So once you've done these, you can check them off yourself. This is a good habit to get into. Now that we've checked those off, we can go ahead and describe our sampling distribution with our shape, our center, and our spread. So our shape should be approximately normal. Our center, so the mean of the p hat should be the P from the proportion of the population that we know. So far we think it's 58%, 0.58. And the standard error of the P hats should be equal to the square root of P times Q divided by N. And that means Q is equal to 1 minus 0.58, which is 0.42. So this is going to be 0.58 times 0.42 divided by 1009, the square root. So make sure you're putting that whole thing under the square root and validate that you get 0.0155. These are what we're using in StatCrunch. Okay? Make sure you've got those down. So D says, find the probability that your sampling proportion of Americans that said they want to ban smoking is bigger than 60%. Give calculator entry, and we don't have to worry about that, but you do need to draw on here that we think the center is at about 58%, and we want to know what is the likelihood that the P hat is bigger than 60. Okay, so we are going to put that into StatCrunch and find out. So let's go to StatCrunch and change our scenario here. And our scenario is 0.58, and our standard error is 0.0155. And we want to see what is it likely that it's more than 60% want to ban smoking in public places. And that is about 9.8% of people. So about 0.098. So that's about 9.8% of people want to ban smoking in public places. Okay, so we're continuing on to the next page, asking some more questions about smoking. So on page 201, it says, what is the probability of obtaining X equals to 548 or fewer adult Americans that support a ban on public smoking? So this time they gave us an X. We don't have a proportion that we're comparing this to. So they gave us X is 548. So we have to figure out what proportion they're talking about. Okay, there's their center. So that would mean that P hat would be 548 out of the 1,009 people that they sampled. What would that be? And so that would be 0.543. And they said, what is the probability of obtaining or fewer? So a less than this 0.543, right? So they want to say or fewer. So we're going over here and we're saying, what is the probability of this? 0.543. So let's check that out in StatCrunch here. So we're changing this to a less than, and this is 0.54. And that is about 0.00849. So not very likely. Not very likely. Next up says, find the 65th percentile or of the sample proportions of the adult Americans from random groups of size n equals 1,009 that support a ban on public smoking. So remember, 65th percentile is from the left over. So that means we're going to, this is right here is the area is 0.65, right? The probability is, where they're saying 65% of people or less believe this. 65% of the samples, okay, are going to have, so let's write that out here in a minute. So this is going to be, this area is 65. Oh, I drew it incorrect. Not incorrect, but I think I covered more than what this is shaded in red. So you'll see my picture here in a minute. And that comes out to be, so this is a sample proportion of 0.586. I'll show you my paper here. So 65 percentile means that 65% of our samples are going to have about 58% of the people that, 58.6% of the people that say that they want to ban public smoking. Letter G says, suppose you conduct your own poll of 1,009 random adult Americans. Would it be unusual to find that more than 61.2% of them support a ban on public smoking? Explain. Would it be unusual to find that more than 61, so that's going to be over here, 0.612. And would it be unusual? So we need to check that. So we're saying, what is the probability that the p hat is bigger than 0.612? So let's find out what that probability is, and we can answer the question. Six one two. And it's 0.9805. So about 98% of the samples should have that. Wow. Would it be more than? Did I do a more than? Let's go back and look at that, because I don't think I did. I did a less than, didn't I? It's actually 0.019. I was going to say, wait, that doesn't seem right. 0.0195. Okay, yep, it was a greater than. That matches our picture that we drew. There we go. There we go. That matches our picture that we drew. So that probably is 0.0195, which is less than 0.05. So yes, it's unusual. Suppose the scenario in part F, actually, part G actually happens. We're talking about this one right here. Suppose this actually happens. List 3 conclusions you might draw with explanations. So the first would be, we had a biased sample of people. It could also be, is just a fluke. And the third could be is maybe the true proportion is not equal to 0.58. Okay, and so that would change all of our outcomes if that were the case. So catch me back for chapter 9. And catch us in the live session to do some practice for all these concepts for chapter 8.